There we go. 2.1 vector odds. Okay, so you have the PHET interactive up here. So there's information here on how to change to PDF if you're still struggling with that. Okay, and then here we sit there and go, okay, so that is just to change the PDF. This is the simulation. So it is this link that is going to have your worksheet in it. So if you click on the actual blue letters, it'll show up at the bottom and then you can go down and top. It is your call if you want to print that out or if you want to open in another sheet and do Kami. As we get later on, it's going to be easier to write it down on a piece of paper, but this one might be helpful to just use Kami with it. It's whatever you want to do. But I find it's often easier to do it on paper so that I can have the simulation and the instructions right here. All right, so we went to the lab, select the second icon. That's going to bring up that guy. And then we need that on here as well. We're doing that 2D thing. Okay. And then you are going to, whoops, you can move your axis. That's not what I want to do. I want to select here. There we go. So drag and drop. And then you can adjust your A any way that you want to adjust it. And you'll see that the dotted ones are showing the X direction, the horizontal, and the Y direction. And are they giving you the information up there? They absolutely are. The resultant vector is 19.7. Theta, our angle, is going to be 30.5. Where is theta? Theta is down here. Okay. And then our X direction on the x-axis is 17 and our y-axis is 10. So there is our little vector information there. Can you turn on all these? Honestly, I try to turn on all of them and then see which one I need. Okay, that blue one though is making it hard to do anything else. So I'm going to turn that one off for right now. Okay, but that one probably is super helpful if you have two vectors that you have to add together. And I go down. And then I would just fill in that chart with that information that I just had up top. Okay, number 5, change it so that they are equal in value. Okay, so you're doing that same thing, but you need this guy to be equal in value. What's the easiest way to do that? You know that these blocks are the same scale. So that would be equal in value, but you can have any one that you want that you sketch in just to show Pythagorean theorem is still working, SOHCAHTOA is still working. Okay, and now change it so it has these numbers. So you're just going to drag it around and then you can write in those numbers or you can complete it using your Pythagorean theorem because at some point they're going to want you to prove it. When you're proving it, you have to verify that the information is correct. So I guess you do have to write it down from the lab here. And then you're proving your vector quantity by doing x squared plus y squared equals your vector squared. And then go through and make sure you write down what you got here so that you can verify that your resultant vector is the same for both. Okay, and how do you prove the angle? You can use any of the SOHCAHTOAs that you want. Okay, and here is to make sure that you're in degrees. I just had you do a couple sample ones of practicing down there. If you're using Desmos and you're at the scientific, you can even just type in sine 45, enter, and it'll get it for you. Okay, and then again, 11 and 12 are just basing off of that Pythagorean theorem. Okay, so you can drag that one in here again. So this time you're setting up the X, Y, and the resultant ones, and then the computer is going to tell you your theta, and then figure it out. Okay. Okay. And now here we have another one. They want you to use SOHCAHTOA here for number 14. So you have an angle of 33.7 degrees, and you have a magnitude. Here we go. You have the X, the Y, you have the resultant. And what are they telling you? Theta here is 37 or 33.7 degrees. And the magnitude of the resultant is 18. So you have these two components here. So you have the angle and the hypotenuse. So then you have to go through and look on your list to figure out how can I find Y and then how can I find X. So you're going to have two different equations on here, one to find a Y and one to find X based on what we've been working on. Yeah, a lot of times just creating. Yep, again, number 17, drag those things in, and then you need to find the X and the Y. So you would need your sine 48 times 13.5. I'm going to put it in front so it doesn't get confused about where the parentheses are. 13.5 times sine 48 is going to give you your vector in the Y. 13.5 cosine 48 is going to give you your vector in the X direction. So you're going to find these out in the lab by dragging it to match those, and then convert and prove them here. Same with number 18. So lots of good vector practice on this one. And there you go.